late November 1942. Tunisian airspace over Bizerte. A Macchi C.202 Folgore fighter screamed through the morning sky, its pilot pulling hard into a defensive turn. The American P-40 Warhawk that had been chasing him broke off, trailing smoke from hits to its engine cowling. The Italian pilot, a veteran of Malta and North Africa, watched the enemy aircraft spiral toward the desert below. His hands shook slightly on the control stick, not from fear, but from the realization of what he had just experienced. The American fighter had absorbed punishment that should have destroyed it. Multiple 12.7mm rounds from his Breda SAFAT machine guns had struck the fuselage, the wings, the tail section. The P-40 had shuddered, pieces of aluminum skin peeling away in the slipstream. But it kept flying, kept maneuvering, kept fighting, until finally engine damage forced the pilot to break contact. The Italian pilot knew his weapons. He had fired thousands of rounds through the Breda SAFAT heavy machine guns mounted in his fighter's nose. He trusted their reliability, understood their characteristics, recognized their distinctive sound. What he did not understand, what no amount of training or experience had prepared him for, was the overwhelming firepower mounted in American aircraft. The P-40 he had just engaged carried 6 Browning M250 caliber machine guns. 6 weapons, each firing the same 12.7mm projectile as his twin Bredas, but heavier, faster, and far more destructive. The combined rate of fire approached 3,600 rounds per minute, more than 5 times what his own aircraft could deliver. This disparity in firepower would define Italian combat experience against American forces for the remainder of the war, revealing truths about industrial capacity and weapons development that Italian engineers had understood for years but could not overcome. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of Italy's 12.7mm Breda SAFAT machine gun began not with recognition of inadequacy, but with measured optimism about indigenous Italian engineering. During the late 1920s, both Breda and SAFAT, a division of Fiat, received contracts from the Regia Aeronautica to develop a new generation of aircraft machine guns. The Italian Air Force needed modern weapons to equip the new monoplane fighters that were replacing the biplanes of the previous generation. Giuseppe Mascarucci, the designer behind the Breda entry, took an American weapon as his starting point. The Browning M, 1921, predecessor to the famous M2, provided the basic operating principles. This was not slavish copying, but practical engineering. John Browning's recoil-operated mechanism had proven reliable in American service. Italian engineers adapted the design to fire ammunition already in Italian inventory, specifically the 12.7 by 81mm semi-rimmed cartridge that Italy had license-produced from British Vickers specifications. The competition between Breda and Fiat SAFAT lasted several years. Fiat, backed by Senator Giovanni Agnelli, and the enormous industrial weight of Italy's automotive giant, expected to win. Their SAFAT subsidiary produced the FIAT Model 1928 Avio in 7.7mm caliber, which the Regia Aeronautica selected for service. But when the larger 12.7mm competition concluded, Breda emerged victorious. Their weapon, lighter than the Fiat SAFAT equivalent by approximately 5 kilograms, offered better power-to-weight characteristics. Fiat contested the decision, launching a lawsuit against Breda. The courts ruled against Fiat, ordering them to pay all trial expenses. Senator Agnelli, infuriated by the defeat, withdrew from the small arms industry entirely, selling SAFAT to Breda. The merger created Breda SAFAT and a new chapter in Italian weapons manufacturing. What had begun as competition between two Italian industrial giants ended with Breda's triumph and Fiat's exit from machine gun production for the next 20 years. The 12.7mm Breda SAFAT that emerged from this process represented sound engineering within the constraints Italian industry faced. The weapon weighed 29 kilograms, lighter than the American Browning M2 at 38 kilograms. It fired at 700 rounds per minute when unsynchronized, dropping to approximately 575 rounds per minute when synchronized to fire through the propeller arc. The muzzle velocity of 765 meters per second placed it in the middle range of contemporary heavy machine guns, adequate for its intended role. Italian pilots who flew with the weapon generally praised its reliability. Unlike some weapons that jammed at high altitude or in extreme temperatures, the Breda SAFAT functioned consistently. Armourer crews appreciated its straightforward maintenance requirements. The weapon fed from belts, avoided complex feed mechanisms, and rarely malfunctioned when properly maintained. The Regia Aeronautica began equipping frontline fighters with the Breda SAFAT in the mid-1930s. The Fiat CR.32 biplane fighter, which would see extensive service in the Spanish Civil War, carried the weapon. By the time Italy entered World War II in June 1940, the 12.7mm Breda SAFAT had become standard armament across Italian fighter aviation. The Fiat CR.42 Falco, the last biplane fighter to see extensive combat in World War II, mounted two Breda SAFATs. The Fiat G.50 Freccia, Italy's first modern monoplane fighter, carried two Breda SAFATs. The Macchi C.200, another early monoplane design, mounted two Breda SAFATs. Italian fighter doctrine centered these weapons as the primary armament, supplemented in some aircraft by lighter 7.7mm Breda SAFAT machine guns in the wings. The ammunition available for the 12.7mm Breda SAFAT included several variants designed for different tactical situations. Armor-piercing rounds used a hardened steel core to penetrate light armor and aircraft structure. Tracer rounds, with their distinctive red tip, allowed pilots to observe their fire and adjust aim. The high-explosive incendiary tracer round, identified by its white tip, carried 0.8 grams of PETN explosive, intended to ignite fuel tanks and damage internal aircraft components. This high-explosive round represented Italian attempts to maximize the destructive effect of their 12.7mm projectiles. The problem was that 0.8 grams of high-explosive material provided minimal blast effect. British armaments. Experts who examined captured Italian ammunition called high-explosive rounds in calibers below 20mm ridiculous, noting that they lacked sufficient explosive content to cause significant structural damage or reliable kills. German, American, and Japanese heavy machine gun ammunition carried between 2.5 and 3 grams of explosive payload when they included high explosive capability at all. Most nations concluded that 12.7mm caliber was too small for effective high explosive projectiles. Italian pilots, aware of these limitations, preferred armor-piercing and incendiary combinations to the weak, high explosive variant. They understood through combat experience that kinetic energy and penetration mattered more than a small explosive charge that rarely produced decisive results. The 12.7 by 81mm cartridge fired by the Breda SAFAT carried a projectile weighing between 33 and 37.5 grams depending on the specific ammunition type. This projectile, lighter than those fired by comparable weapons from other nations, achieved its 765 meters per second muzzle velocity through moderate propellant charges. Italian ammunition manufacturing used lower propellant capacity than American, Soviet, German, or Japanese 12.7mm cartridges, a design choice that simplified production but resulted in reduced ballistic performance. The technical specifications seemed adequate on paper. Italian engineers in the mid-1930s had created a reliable, lightweight aircraft weapon that fired a reasonably effective projectile. The Breda SAFAT compared favorably with other heavy machine guns of its era when first introduced. The problem emerged not from poor design, but from the pace of development elsewhere. By 1940, when the real test of combat began, other nations had surpassed Italy's capabilities. The American Browning M2 fired a 12.7 by 99mm cartridge with a 43-gram projectile at 890 meters per second, delivering substantially more kinetic energy at all ranges. The Soviet Berezin UB fired a 12.7 by 108 mm cartridge with similar performance characteristics. The German MG 131, though slightly smaller at 13 mm caliber, achieved 710 meters per second with a 38-gram projectile. Even the Japanese Ho 103, using the same 12.7 by 81 mm cartridge as the Italian Breda, achieved higher rates of fire, between 800 and 900 rounds per minute, through a lighter weapon design. Italy entered World War II with aircraft armament that had been adequate in 1935, but was obsolete by 1940. The standard Italian fighter carried two 12.7 mm Breda SAFAT machine guns, sometimes supplemented by two 7.7 mm Breda SAFATs. This represented roughly the same firepower as the Fiat CR.32 biplane fighter of the Spanish Civil War era, a comparison that Italian pilots found deeply troubling. German Messerschmitt Bf 109s of the same period carried two 13 mm MG1 3-1s and two 20 mm MGFF cannons. British Spitfires mounted 8 7.7 mm Browning machine guns, later upgraded to 4 20 mm Hispanic cannons. American P-40 Warhawks carried 650 caliber Browning M2 machine guns. The firepower gap was not subtle. It was overwhelming and immediately apparent to anyone who flew combat missions. June 10, 1940. Italy declared war on France and Britain. Italian fighters based in Libya began operations against British positions in Egypt and against Malta. The Fiat CR.42 Falco biplane fighters of the Regia Aeronautica, flown by skilled and ACO, experienced pilots, initially achieved successes against Royal Air Force Gloucester Gladiator biplanes. These early encounters suggested that Italian training and tactical doctrine could offset any equipment deficiencies. The Gladiator, also a biplane and only marginally more modern than the CR.42, carried four 7.7 mm machine guns. Italian pilots with their two 12.7 mm Bredas found themselves roughly equal in firepower and superior in maneuverability. These initial victories created dangerous optimism within Italian military circles about the adequacy of existing equipment. The illusion shattered when the British introduced Hawker Hurricane monoplanes to the Mediterranean theatre. The Hurricane, already considered obsolescent by Royal Air Force standards after the Battle of Britain, carried 8 7.7 mm Browning machine guns that could fire over 10,000 rounds per minute combined. Italian pilots, attempting to engage Hurricanes, discovered that British defensive fire, even from supposedly inferior aircraft, vastly exceeded anything Italian fighters could deliver. A Hurricane that should have been easy prey, being slower and less maneuverable than the latest Italian fighters, instead became a dangerous opponent purely through overwhelming firepower. The Hurricane could afford to spray bullets across large areas of sky, knowing that probability alone would produce hits. Italian pilots, limited to 2 machine guns and conscious of finite ammunition supplies, needed precise gunnery to achieve kills. Precision required time. Time meant exposure. Exposure meant vulnerability to return fire. The entry of American forces into the Mediterranean theatre in late 1942 transformed the firepower equation entirely. Operation Torch. The Allied landings in North Africa beginning November 8, 1942, brought American fighters and bombers into combat against Axis forces. Italian pilots who had adapted to British firepower superiority now faced an even more daunting challenge. The Curtiss P-40 Warhawk, America's primary fighter in the theatre, mounted 650 caliber Browning M2 machine guns. Some variants carried the Packard Merlin engine that improved high-altitude performance. But the real revelation for Axis pilots was the devastating defensive fire these aircraft could generate. A single P-40 could fire approximately 4,800 rounds per minute from its 6 Brownings. A formation of 4 P-40s meant 24 heavy machine guns firing simultaneously, creating intersecting streams of fire that made attack runs suicidal. Italian fighter pilots, accustomed to carefully stalking their prey and selecting optimal attack angles, found that American formations simply saturated entire sectors of airspace with bullets. The tactical doctrine was fundamentally different from anything European air forces practiced. Americans did not conserve ammunition. They fired continuously, trusting that volume would compensate for any lack of precision. Italian pilots watching tracer streams arc across the sky at night could calculate the terrible mathematics. Every fifth round was a tracer, visible to the naked eye. For every tracer they saw, 4 additional projectiles followed the same path. A burst that showed 10 tracers meant 50 rounds in the air. Multiply that across 6 guns, across multiple aircraft, and the result was a wall of steel that no amount of skill or courage could penetrate safely. The Browning M2 projectile itself compounded Italian disadvantages. The standard American 12.7 by 99 mm armor-piercing incendiary round weighed 43 grams and carried 2% of its weight as explosive content. This translated to approximately 0.86 grams of explosive material, slightly more than the Italian high-explosive rounds. But the real advantage came from kinetic energy. The heavier American projectile, traveling at 890 meters per second, carried approximately 17,000 joules of kinetic energy at the muzzle. The Italian 12.7 by 81 mm round, with its 34-gram projectile at 765 meters per second, delivered approximately 10,000 joules. The American round hit with 60% more kinetic energy, enough to punch through structures that would stop or deflect Italian projectiles. Italian pilots reported watching their hits strike American aircraft without producing the devastating results they expected. Bullets that should have caused critical damage instead produced holes that American aircraft seemed able to ignore. P-40s absorbed punishment that would have destroyed Italian fighters, limping home with damage that testified to both superior American aircraft construction and the inadequacy of Italian weaponry. November 16, 1942. The air battle over Tunisia. Elements of the Regia Aeronautica engaged American P-40 Warhawks escorting bomber formations. The Italian pilots, flying Macchi MC.202 Folgore fighters, powered by license-built German Daimler-Benz engines, represented the peak of Italian fighter capability. The Folgore was fast, maneuverable, and well liked by its pilots, but it still carried only 2 12.7 mm Breda SAFAT machine guns. The resulting combat demonstrated the firepower disparity in brutal clarity. Italian pilots made attack passes, fired their weapons, saw hits register on American aircraft, and watched in frustration as the targets continued flying. Return fire from American formations damaged Italian aircraft that lacked the robust construction of their opponents. The battle ended with losses on both sides, but the trend was clear. American aircraft could sustain more damage and deliver more firepower than Italian fighters could match. Teresio Martinoli, one of Italy's most successful fighter pilots with over 20 confirmed victories, flew Macchi MC.202 fighters in North Africa during this period. His combat reports documented encounters with American P-40s and P-39s that revealed his professional assessment of American advantages. Martinoli shot down 2 P-40 Warhawks in mid-1942, damaging a third, demonstrating that skill and tactics could produce victories even against superior firepower. But his reports noted the difficulty of achieving kills against American aircraft, the need for precise shot placement, and the danger of American defensive fire. Each successful engagement required careful stalking, patience, and perfect execution. Mistakes meant death or damage severe enough to force retreat. American pilots, by contrast, could afford more aggressive tactics, knowing their .650 caliber machine guns gave them firepower advantages that compensated for less refined technique. The industrial dimensions of the firepower gap became apparent to Italian military leadership through intelligence reports and pilot debriefings throughout 1942 and 1943. American factories produced Browning M2 machine guns by the hundreds of thousands. The AN-M2, the aircraft variant of the weapon, equipped virtually every American combat aircraft. Boeing B-17 Flying Fortress bombers carried 13 Brownings, creating defensive firepower that German and Italian fighter pilots found nearly impossible to penetrate without suffering catastrophic losses. Consolidated, B-24 Liberator bombers carried 10 Brownings. Even American transport aircraft mounted Brownings for self-defense. The United States had achieved universal heavy machine gun coverage across its entire air fleet, something no other nation attempted or could afford. Italian industry, struggling with raw material shortages and limited industrial capacity, could barely produce enough Breda SAFATs to equip frontline fighters, let alone mount them on every aircraft type in inventory. The ammunition production disparity exceeded even the weapons manufacturing gap. American factories produced 12.7mm ammunition, literally by the billions of rounds. Ships crossing the Atlantic carried tons of .50 caliber ammunition to supply Allied forces in every theater. American fighters landed after missions, ground crews reloaded them with fresh ammunition belts, and the aircraft returned to combat within hours. This cycle repeated daily, sometimes multiple times per day. Italian fighters, by contrast, operated under chronic ammunition shortages. Pilots received instructions to conserve ammunition, to fire only when confident of hits, to return to base with rounds remaining rather than expend everything in hopeful spraying. The difference in operational philosophy reflected industrial reality. America could afford to waste ammunition, Italy could not. September 1942. Sicily. An Italian fighter pilot named Luigi Gorini, flying a Macchi C.202, engaged British and American aircraft over the Mediterranean. Gorini would survive the war as one of Italy's few surviving aces, achieving 19 confirmed victories, including P-38 Lightnings and other American types. His post-war accounts described the evolution of aerial combat as American forces entered the theater. Early in the war, Italian fighters could achieve local air superiority through superior tactics and pilot skill. By late 1942, American numbers and firepower made air superiority impossible to maintain. Italian pilots adapted by becoming more cautious, by striking only when conditions favored them, by retreating when faced with superior American formations. This defensive mentality, forced by material inferiority, meant ceding initiative to the Allies and accepting a grinding war of attrition that Italy could not win. Italian engineers understood the technical gap. They had access to captured British and American aircraft, studied the weapons and ammunition, conducted tests and evaluations. The Regia Aeronautica Technical Services produced reports documenting Browning M2 specifications, noting the superior muzzle velocity, heavier projectile weight, and greater kinetic energy. These reports circulated through military and industrial channels, providing detailed technical data that confirmed what pilots reported from combat. The Breda SAFAT was a reliable, well-engineered weapon that fulfilled the requirements it had been designed to meet. The problem was that those requirements, established in the mid-1930s, no longer matched combat realities of the 1940s. Other nations had continued developing their weapons, increasing performance through improved ammunition and higher manufacturing standards. Italy, constrained by limited industrial capacity and chronic shortages of strategic materials, could not match this development pace. The Italian response to recognized firepower inadequacy took multiple forms, none of them entirely successful. One approach involved improving the Breda SAFAT itself. Engineers worked to increase the rate of fire, reduce weight, and improve reliability. These incremental improvements helped, but could not overcome the fundamental limitation of the 12.7 by 81mm cartridge. Without more powerful ammunition, the weapon would remain outclassed regardless of mechanical refinements. Developing new ammunition required industrial capacity to produce new propellants, brass casings to different specifications, and testing programs to validate performance. Italy attempted some ammunition development but never achieved production at scales that mattered operationally. The second approach involved supplementing the Breda SAFAT with cannons of larger caliber. 20mm cannons, specifically, the German Mauser MG 151, appeared on Italian fighters beginning in 1943. The Macchi MC.205 Veltro, Fiat G.55 Centauro, and Reggiane Re.2005 Sagittario, Italy's most advanced fighter designs, carried combinations of Breda SAFAT machine guns and German cannons. Some variants mounted 3 MG151s in addition to 2 Breda SAFATs, providing firepower roughly comparable to Allied fighters. The cannon shells, with explosive payloads measured in grams rather than fractions of grams, could destroy aircraft with single hits when they connected. Italian pilots who flew these late war fighters praised their effectiveness, noting that finally they possessed weapons that could compete with Allied armament. The problem was numbers. These advanced fighters entered service in limited quantities during 1943 and 1944, too late and too few to affect the war's outcome. Italian industry, disrupted by Allied bombing, resource shortages, and the collapse of Axis fortunes, could not produce them in quantities sufficient to re-equip fighter squadrons. Most Italian pilots flew earlier generation aircraft with inferior armament until the armistice of September 8, 1943, split Italy into Allied and Axis-aligned factions. The third approach involved tactical adaptation. Italian fighter pilots developed techniques to maximize their limited firepower advantages. They learned to stalk carefully, closing to point-blank range before opening fire to ensure maximum hit probability. They learned to target vulnerable components, aiming for engines and cockpits, rather than hoping for general fuselage hits. They learned to attack from angles that minimized exposure to return fire, particularly the deadly blind spots where American bomber defensive weapons could not engage effectively. These tactics worked when perfectly executed by experienced pilots under ideal conditions. But perfect execution was rare, experience was dying with each combat loss, and conditions were rarely ideal. The tactical sophistication required to overcome firepower inferiority meant that only the best Italian pilots could achieve consistent success. Average pilots, facing American aircraft with 650 caliber machine guns, simply died. The psychological dimension of the firepower gap affected Italian pilot morale in ways that technical reports could not fully capture. Italian pilots were not cowards. They were skilled aviators, many with extensive combat experience across multiple theaters. But repeated encounters with American firepower created accumulating stress that eroded combat effectiveness, even when pilots survived physically unharmed. Watching comrades shot down by overwhelming fire, surviving missions where luck rather than skill determined outcomes, knowing that technical inferiority meant every engagement carried heightened risk, these factors generated combat fatigue that degraded unit cohesion and fighting spirit. Italian squadron commanders reported increasing reluctance among pilots to engage when they identified American formations. This was not cowardice, but rational calculation. Attacking meant accepting high probability of death or severe damage in exchange for low probability of achieving meaningful results. Professional soldiers recognized futile gestures for what they were and avoided them when possible. By early 1943, the pattern had become undeniable across all theaters where Italian and American forces clashed. In North Africa, Italian fighters struggled against Allied air superiority, enabled partially by American firepower advantages. In Sicily, during the Allied invasion beginning July 1943, Italian fighters faced overwhelming numbers of American aircraft, each carrying firepower that Italian pilots could not match. Over mainland Italy, as Allied bombers struck targets throughout the Poricli Peninsula, Italian interceptors discovered that bomber defensive fire from massed Browning M2 machine guns created barrier walls of lead that made successful attacks nearly suicidal. The mathematics were simple and brutal. American aircraft carried more guns. American guns fired heavier projectiles at higher velocities. American ammunition was available in essentially unlimited quantities. Italian aircraft, Italian guns, and Italian ammunition could not compete with this material superiority. The final campaigns in the Mediterranean theatre demonstrated conclusively what Italian engineers had known, but could not remedy. American industrial capacity had produced not just superior weapons, but an entire system of warfare built on material expenditure that made traditional European military calculations obsolete. The Browning M250 caliber machine gun was merely the most visible symbol of this system. Behind each gun stood factories producing ammunition by the trainload, logistics, networks delivering supplies without interruption, and a military doctrine that accepted wasteful expenditure as the price of victory. Italian military planners, trained in European traditions of conservation and efficiency, found themselves facing an opponent who solved tactical problems through overwhelming application of resources rather than clever use of limited means. April 1943. The final Axis resistance in North Africa collapsed. Over 250,000 German and Italian troops surrendered in Tunisia, marking the complete Allied victory in the theatre. The air war had been decided months earlier. Italian fighter units, reduced to handfuls of operational aircraft through combat losses and chronic maintenance problems caused by parts shortages, could no longer contest Allied air superiority. On May 8, 1943, Spitfires caught 40 Macchi C.202 fighters of the 7th and 16th, Gruppo, 54th Stormo, concentrated at Corba Airfield. The resulting massacre destroyed nearly all Italian aircraft on the ground. Only 11 fighters were repaired by May 10th and evacuated to Italy, each carrying 2 men, a pilot and a mechanic, because no transport aircraft remained available. This humiliating retreat symbolized the complete collapse of Italian air power in North Africa. During the Tunisian campaign, the Regia Aeronautica lost 22 C.202s in air combat and 47 destroyed on the ground. The disparity told its own story. More Italian fighters were destroyed on the ground than shot down in combat, indicating that Allied air superiority had become so complete that Italian aircraft could not even launch effectively. The technical limitations of the Breda SAFAT became strategic liabilities when examined through the lens of industrial production capacity. A comparison of aircraft armament across different nations revealed Italy's fundamental disadvantage. American P-47 Thunderbolt fighters, entering service in 1943, carried 8 Browning M, 2 machine guns with approximately 3,400 rounds total ammunition capacity. This single aircraft could deliver firepower equivalent to roughly 6 Italian fighters, each with their 2 Breda SAFATs. German Focke-Wulf 190 fighters carried 4 20mm cannons and 2 13mm machine guns, providing devastating firepower, but requiring complex logistics for multiple ammunition types. British Hawker Typhoon fighters mounted 4 20mm cannons. Soviet Yakovlev Yak-9 fighters typically carried 1 20mm cannon and 1 or 2 12.7mm Berezin machine guns. Every major combatant nation had developed fighters with firepower that exceeded Italian standards. The Regia Aeronautica's continued reliance on 2 Breda SAFATs as standard armament into 1943 placed Italian pilots at systematic disadvantage against every opponent they faced. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The industrial analysis painted an even grimmer picture. The United States produced approximately 2 million Browning machine guns of all types during World War II, including hundreds of thousands of the M250 caliber variant. American factories also produced over 20 billion rounds of small arms ammunition during the war, including billions of 50 caliber rounds. These production numbers exceeded the entire output of Italian industry by orders of magnitude. Italy, with its limited industrial base and chronic shortages of strategic materials including steel, aluminum, copper, and gunpowder precursors, simply lacked the capacity to match American production, even if Italian engineers had designed superior weapons. The Breda SAFAT was not inferior because Italian engineers lacked knowledge or skill. It was inferior because Italian industry could not support development and production of more capable weapons, while simultaneously meeting all other military requirements. The question of why Italy failed to develop more powerful aircraft armament requires understanding the broader context of Italian industrial mobilization. Unlike Germany, which had been preparing for war throughout the 1930s and had built extensive armaments industries, Italy entered World War II with an economy primarily oriented toward civilian production. Benito Mussolini's declarations of military strength were propaganda unsupported by industrial reality. The Italian army lacked modern tanks, adequate artillery, and sufficient motor transport. The Italian navy had impressive battleships but chronic fuel shortages that limited operations. The Regia Aeronautica flew obsolete aircraft in quantities insufficient for sustained operations. Every branch of Italy's military faced equipment shortages and industrial capacity constraints that prevented modernization at necessary scales. Aircraft armament development competed for resources against all other military requirements. Developing improved heavy machine guns required metallurgy research, ammunition testing, factory retooling, and establishment of new production lines. Every engineer assigned to machine gun development was an engineer not working on aircraft engines, airframe improvements, or radar systems. Every ton of steel allocated to machine gun production was steel not available for artillery shells, tank armor, or ship construction. Italian military planners faced impossible choices about resource allocation, knowing that every decision meant accepting deficiencies elsewhere. The Breda SAFAT continued in production through 1944, not because Italian engineers believed it was adequate, but because replacing it would require industrial investments that Italy simply could not afford given all competing priorities. The captured equipment that Italian forces occasionally obtained from Allied forces provided painful reminders of industrial disparities. When Italian ground forces captured American vehicles in Tunisia, they discovered 50 caliber Browning M2 machine guns mounted on jeeps, trucks, half-tracks, and tanks. The Americans had achieved universal heavy machine gun coverage across their entire force structure, mounting weapons on vehicles that Italian forces would never have considered worthy of such valuable armament. Italian soldiers examining these captured weapons could physically hold the difference in their hands. The Browning M2 was heavier, more solidly constructed, manufactured to tighter tolerances, and supplied with ammunition in quantities that seemed incomprehensible. American vehicles carried hundreds or thousands of rounds of 50 caliber ammunition as standard load. Italian vehicles, when they mounted heavy machine guns at all, carried minimal ammunition loads, dictated by chronic shortages. The September 8, 1943 armistice split Italy into two zones and ended the Regia Aeronautica as a unified force. Southern Italy, controlled by Allied forces, saw Italian pilots who sided with the Allies form the Aviazione Co-Belligerante Italiana, the Italian co-belligerent air force. These pilots flew alongside Allied squadrons, often operating Allied aircraft, including American types equipped with Browning machine guns. Northern Italy, controlled by German forces and the Italian Social Republic under Mussolini, maintained the Aeronautica Nazionale Repubblicana, the National Republican Air Force. This force continued operating Italian aircraft, including the advanced Macchi C.205, Fiat G.55, and Reggiana Re.2005 fighters, armed with combinations of Breda SAFAT machine guns and German 20mm cannons. The Italian pilots who flew these late-war fighters in defense of northern Italy finally possessed armament roughly equal to Allied standards. The three 20mm MG151 cannons, firing through the propeller hub and mounted in the wings, provided devastating firepower. Italian pilots shot down American P-38 Lightnings, P-47 Thunderbolts, and P-51 Mustangs in combat during 1944 and early 1945, demonstrating that when equipment permitted, Italian pilot skill remained formidable. But these victories came too late and in insufficient numbers to affect outcomes. The Aeronautica Nazionale Repubblicana never fielded more than a few dozen of these advanced fighters simultaneously. Most Italian pilots continued flying earlier generation aircraft with inferior armament until the end of hostilities. Luigi Gorini, the ace who survived the war, flew both earlier Macchi variants with two Breda SAFATs and later versions equipped with German cannons. His post-war accounts described the transformation in combat effectiveness that adequate firepower provided. With two Breda SAFATs, achieving kills required perfect stalking, ideal positioning, and precise gunnery. A single mistake meant losing the opportunity and probably taking damage from return fire. With 3 20mm cannons plus 2 Breda SAFATs, he could engage more aggressively, knowing that hits would produce devastating results. The cannon shells, each carrying substantially more explosive than entire belts of Breda SAFAT ammunition, destroyed aircraft with single, well-placed shots. Gorini's experience validated what Italian engineers had argued throughout the war. Given adequate weapons, Italian pilots could compete successfully against any opponent. The problem had never been training, tactics, or courage. The problem was industrial capacity insufficient to provide adequate weapons in necessary quantities. The final accounting of Italian air combat effectiveness revealed patterns consistent across all theatres and time periods. During the early war years, when Italian pilots faced British and Commonwealth forces equipped with comparable weapons, Italian fighter units achieved respectable kill-to-loss ratios through superior tactics and pilot skill. The Macchi C.202, despite carrying only 2 Breda SAFATs, achieved better than 4-to-1 kill ratios against Hurricanes and P-40s during certain periods in North Africa during mid-1942. Italian pilots, making maximum use of their aircraft's excellent maneuverability and their weapons' reliable performance, could achieve local tactical victories. But as American forces entered the theatre in growing numbers, bringing overwhelming firepower and unlimited ammunition, Italian effectiveness collapsed. By late 1943 and throughout 1944, Italian fighter units faced casualty ratios that exceeded even the worst periods of the Battle of Britain. Pilots and aircraft were dying faster than training. Programs and factories could replace them. The comparison with German Luftwaffe experience fighting American bomber formations revealed similar patterns despite Germany's superior industrial capacity. German fighter pilots, equipped with combinations of machine guns and cannons, attacked American bomber boxes protected by massed 50-caliber Browning defensive fire. The Germans achieved far higher kill ratios against American bombers than Italian pilots ever managed, but they paid catastrophic prices in pilot casualties. Luftwaffe fighter losses to bomber defensive fire exceeded losses to American escort fighters during many missions. The Browning M2, mounted by the dozens on heavy bombers, created defensive firepower that no attacking fighter could safely penetrate. German fighters, equipped with 30mm cannons that could destroy bombers with single hits, still faced the problem of surviving long enough to reach effective firing positions. The defensive fire from 13 Brownings per B-17, multiplied across formations of dozens or hundreds of bombers, created barrier walls that destroyed attacking fighters before they could close to cannon range. Italian engineers who studied reports from German sources understood that even substantially better armament than the Breda SAFAT provided no guarantee of success against American firepower doctrine. The German MG 151 20mm cannon, which Italy licensed, produced and installed on late-war fighters, was an excellent weapon by any technical standard. Yet German pilots armed with multiple MG 151s still struggled against American bomber defensive fire. The fundamental problem was not weapon quality but system design philosophy. American military doctrine accepted that defensive firepower through massed machine guns was more effective than attempting to destroy every attacking fighter through superior individual weapon performance. German and Italian doctrine both emphasized weapon efficiency and ammunition conservation, assuming that limited industrial capacity required careful resource management. American doctrine rejected these constraints entirely, instead building an industrial system capable of producing and supplying weapons in quantities that made conservation unnecessary. The post-war assessment of the Breda SAFAT's service life reflected this doctrinal conflict. Italian military historians, analyzing the weapon's performance without nationalist bias or propaganda requirements, concluded that the Breda SAFAT was a competent weapon that fulfilled its design requirements adequately. Giuseppe Mascarucci, the designer, had created a reliable aircraft machine gun using proven operating principles and indigenous Italian ammunition. The weapon rarely jammed, operated in extreme temperatures and altitudes, and could be maintained by competent armourer crews without specialized equipment. Italian pilots who flew with Breda SAFATs throughout the war consistently praised the weapon's reliability. These were not trivial achievements. Many weapons that appeared superior on paper failed under combat conditions through reliability problems, maintenance difficulties, or ammunition supply failures. The Breda SAFAT worked when needed, which was more than could be said for some theoretically superior designs. The problem was that reliability alone could not overcome kinetic energy deficiencies and firepower disparities. The 12.7 by 81 mm cartridge, regardless of how reliably it was fired, delivered insufficient kinetic energy at combat ranges to guarantee kills against ruggedly constructed American aircraft. The decision to base the Breda SAFAT on this cartridge, made in the early 1930s, when it represented reasonable compromise between power and manufacturing complexity, locked Italy into an inferior ammunition standard for the entire war. Developing new ammunition would have required extensive industrial investment and years of development time. Italy possessed neither the resources nor the time to pursue such programs, while simultaneously fighting on multiple fronts. The result was that Italian pilots flew throughout World War II with weapons that were adequate in 1935 but obsolete by 1940, knowing that they faced opponents with superior firepower but unable to do anything about the disparity. The broader industrial dimensions of Italian military failure contextualized the Breda SAFAT story within larger patterns of resource constraints and strategic miscalculation. Mussolini had led Italy into World War II, believing that the conflict would end quickly through German victory, allowing Italy to gain territorial concessions without prolonged fighting. This assumption proved catastrophically wrong. The war extended for years, requiring sustained industrial mobilization that Italy's economy could not support. Chronic shortages of oil, coal, steel, aluminum, rubber, and other strategic materials crippled Italian military production. Factories lacked raw materials to operate at capacity. Transportation networks lacked fuel to move supplies efficiently. The military lacked equipment to replace combat losses. These cascading failures affected every aspect of Italian war production, including aircraft armament. The Breda Company, manufacturer of the SAFAT machine guns, also produced numerous other weapons systems, including light machine guns, anti-aircraft cannons, and tank armament. The company's production capacity was divided among these competing requirements, none of which could be fully satisfied given resource constraints. Engineers at Breda were aware of the Breda SAFAT's limitations compared to American weapons. They had access to captured equipment, technical intelligence reports, and pilot feedback documenting the firepower gap. But knowing about problems and possessing resources to fix them were entirely different matters. Breda could not independently decide to develop improved machine guns and ammunition. Such decisions required government approval, resource allocation, and coordination across multiple ministries and military branches. The bureaucratic and industrial complexity of weapons development during wartime meant that even obviously necessary improvements might never be implemented if resources were unavailable or priorities lay elsewhere. The Italian experience with the Breda SAFAT machine gun illustrated broader lessons about industrial warfare that became apparent to military historians only through post-war analysis. Modern warfare between industrialized nations was ultimately decided not by tactical brilliance or operational art, but by industrial capacity and logistics sustainability. The side that could produce more weapons, supply more ammunition, and replace losses faster would prevail regardless of relative weapon quality or tactical skill. Germany learned this lesson on the Brevity Eastern Front, where Soviet industrial capacity eventually overwhelmed German technical superiority through sheer weight of numbers. Japan learned this lesson in the Pacific, where American shipbuilding capacity produced fleets faster than Japanese forces could sink them. Italy learned this lesson in the Mediterranean, where American and British industrial advantages created material superiority that Italian forces could not overcome through any combination of courage, skill, or tactical innovation. The Breda SAFAT itself continued in Italian service long after World War II ended. The weapon's reliability and straightforward maintenance made it suitable for reserve and training roles. Italian forces used Breda SAFAT machine guns in anti-aircraft mountings and ground installations through the 1970s, decades after the design's combat obsolescence became apparent. This longevity testified to sound basic engineering, even as it confirmed that the weapon's combat effectiveness had been surpassed by more modern designs. The final Breda SAFATs were retired only when ammunition supplies were exhausted and replacement parts became unavailable, ending a service life that spanned 4 decades from initial adoption in the 1930s to final retirement in the 1970s. The legacy of the Breda SAFAT in Italian military history is complex and somewhat paradoxical. The weapon represented both genuine Italian engineering competence and the fundamental inadequacy of Italian industrial capacity for modern warfare. Giuseppe Mascarucci and his team at Breda created a weapon that functioned reliably under combat conditions, no small achievement in an era when many theoretically superior designs failed operationally. But reliability could not compensate for insufficient kinetic energy and inadequate numbers. Italian pilots flew throughout World War II knowing their weapons were outclassed, understanding that industrial limitations prevented improvements, and recognizing that tactical skill alone could not overcome material inferiority. This knowledge, the certain understanding that they fought with inadequate tools against better-equipped opponents, created psychological burdens that affected combat effectiveness as surely as the technical specifications of their weapons. The broader question of whether Italy could have developed superior aircraft armament given different strategic choices remains subject to historical debate. Some historians argue that earlier recognition of firepower inadequacy might have prompted development programs that produced better weapons by 1942 or 1943. Others contend that Italian industrial capacity was so constrained by resource shortages that no amount of planning or foresight could have significantly improved weapons performance. The truth likely lies between these extremes. Better planning and higher priority allocation to aircraft armament might have produced incremental improvements, perhaps increasing Breda SAFAT projectile velocity or developing explosive rounds with greater effectiveness. But fundamental limitations of Italian industrial capacity would have prevented matching American or German firepower regardless of planning quality. Italy simply lacked the steel production, chemical industry, and machine tool capacity to compete with major industrial powers in arms production. The story of Italian engineers and the Breda SAFAT is ultimately a story about the limits of technical competence in an industrial age. Giuseppe Mascarucci was a skilled weapons designer who created a functioning machine gun using available resources and technology. Italian pilots were brave and skilled aviators who maximized the effectiveness of the weapons they were given. Italian factory workers produced Breda SAFAT machine guns to the limits of available industrial capacity, but none of this effort, skill, or courage could overcome the fundamental disparity between Italian and American industrial systems. The United States had built its economy around mass production and standardization through decades of automotive industry development. American factories could produce weapons in quantities that Italian industry could not approach. American logistics networks could deliver supplies that Italian networks could not match. American military doctrine reflected this industrial reality, building tactics and strategy around material expenditure rather than conservation. The final missions of the Aeronautica Nazionale Repubblicana in April and May 1945, as Allied forces overran northern Italy, saw Italian pilots flying sortie after sortie against overwhelming odds. The handful of advanced fighters equipped with German cannons achieved occasional victories, but the outcome was never in doubt. American air superiority was absolute. Italian pilots who survived the war carried memories of fighting with inadequate weapons against opponents, whose firepower seemed unlimited. Luigi Gorini, Teresio Martinoli, and others who lived to tell their stories consistently emphasized the same themes. Italian pilots were not inferior to their opponents in skill, courage, or determination. Italian aircraft, particularly later models like the Macchi C.205 and Fiat G.55, were excellent machines comparable to the best Allied fighters, What Italian pilots lacked was firepower, matching their opponents, and numbers sufficient to contest air superiority. The Breda SAFAT, reliable and well-engineered as it was, simply could not compete with the Browning M2 in terms of projectile performance, and Italian industry could not produce enough weapons of any type to match American quantities. The post-war Italian Air Force, reconstituted as the Aeronautica Militare in 1946, following the end of the monarchy, faced the challenge of complete re-equipment. Italian aircraft production had been devastated by Allied bombing and the chaos of the war's final years. The new Air Force required modern aircraft and weapons, none of which Italian industry could immediately provide. American military aid through the Mutual Defense Assistance Program brought P-47 Thunderbolts and P-51 Mustangs to Italy, giving Italian pilots their first experience with the very weapons that had dominated them during the war. The 8 Browning M2 machine guns in the P-47 represented firepower that Italian pilots had faced but never possessed during combat. Flying these aircraft, Italian pilots could finally understand from the offensive perspective what defensive fire from massed 50-caliber machine guns meant. The experience validated everything they had reported during the war about American firepower superiority. The lessons learned from the Breda SAFAT experience influenced Italian military procurement and doctrine for decades after World War II. Italian military planners recognized that future conflicts would require industrial capacity to support sustained operations, and that tactical skill could not compensate for material inferiority. NATO membership, beginning in 1949, integrated Italy into a collective defense system that provided access to advanced weapons and shared industrial capacity. Italian forces no longer needed to rely solely on indigenous weapons production, instead participating in collaborative development programs with other NATO nations. The Italian defense industry rebuilt gradually, eventually producing excellent aircraft and weapons systems. But the memory of fighting with inadequate equipment against better armed opponents remained influential in Italian military culture, creating institutional emphasis on maintaining technological parity with potential adversaries. The Breda SAFAT machine gun, examined objectively without nationalist prejudice or propaganda requirements, represents a case study in the relationship between engineering competence and industrial capacity during modern warfare. The weapon was well designed within the constraints its engineers faced. It was reliably manufactured using available resources and technology. It was effectively employed by skilled pilots who understood its capabilities and limitations. But all this competence and effort could not overcome fundamental industrial disparities between Italy and the United States. American factories produced more weapons, better ammunition, and endless supplies. American military doctrine built tactics around material expenditure that Italian forces could not match. The result was predictable and inevitable. Italian pilots fought bravely with the weapons they had, achieved local tactical successes when conditions permitted, but ultimately faced defeat through overwhelming material superiority they could not counter. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.